Welcome back to our second video on coordinate geometry. In this video today, we're going to look at the equation of a straight line, looking at the gradient-intercept form, and we'll also manipulate the point gradient form to have us put our equation in what we call the gradient-intercept form or the slope-intercept form. Now, my disclaimer, please note that these videos that I provide for now are not full teaching videos. They are just videos that help you guys to remember some of the concepts quickly. Alright? So let's get to the point. The gradient intercept form is y equal mx plus c, or in some textbooks they may use y equal mx plus b. Now in our equation we have a lot of variables here. We have y, we have x, we have m, and we have c. Now common m that we use for gradient that you can see in the video above, so check the link if you have not seen the first video on gradient. Now m stands for the gradient and c stands for the y-intercept. Now we can look at our graph here, and this c here is what we call the y-intercept. It's where the straight line cuts the y-axis. And we know our gradient using our rise. So here will be our rise, and here will be our run. So we have our gradient, rise over run, and c is our y-intercept. Now normally the y-intercept takes the gradient of, takes the coordinate 0, c. Now just a quick activity, write down the gradient and the y-intercept for each of the lines below. Now let's write back our gradient intercept form or a slope intercept form. So we have y equal mx plus c, where m is our gradient and c is our y-intercept. Now note briefly and note pencilly that before we can go ahead and write down the gradient and the y-intercept, we must ensure that each equation given is in the form y equal mx plus c. So for instance, in the example that we call A, we have y equal 4x minus 1. So this is in the form y equal mx plus c. And we can go ahead and match where we see m, or not match, compare. So we can see that the value of m is equal to 4 and the value of c is equal to -1. Now let's look at b here. So we have y is equal to 1/3 x plus 3. Let's compare. Is this in the form y equal mx plus c? Yes, laugh at me stuttering. That's part of it too. So we have y equal mx plus c. By comparison, we can see that m, which is our gradient, is 1/3 and c, our y-intercept, is 3. Now let's look at c. Now remember, in order to tell what the gradient is, even though there are persons who can look at this equation and tell me what the gradient and the y-intercept is, for other students they may need to rearrange the formula to make y the subject. So for all those who are afraid of transposing, it's just maths, baby maths, not hard. Now we're going to write this equation in the form of y equal mx plus c. So we have x plus y plus 3 is equal to 0. Now the first step you can work is multiple ways. Multiple ways. Nobody's going to stop you to do what you want to do. I'm just going to do this quick and fast. So we have y plus 3. Let's say we want to get rid of x on both sides. So we have minus x is equal to 0 minus x. So then our x goes. So we have y plus 3 is equal to minus x. Next, still not in the form y equal mx plus 3. So I'm going to subtract 3 from both sides of the equation. So now I have y plus 3 minus 3 is equal to minus x minus 3. So hence, y plus 0, same thing as y, is equal to minus x minus 3. Now we have this in our form, y equal mx plus c. And by comparison, we can tell that our m is equal to negative 1, because negative x is the same thing as saying negative 1x. Alright? And our c is going to be negative 3. Now, let's look at d. Now, by a quick glance, we can already realize that d is in the form y equal mx plus c. So by comparison, m is equal to negative 2, and our y-intercept, which is c, is equal to negative 3 over 5. Quick activity, nice. The first thing we need to ensure that each equation is in the gradient or the slope-intercept form, which is y equal mx plus c. Now, let's do a quick practice. Sorry. Let's edit that out. And cut. Go. Now, let's do a quick practice. So we're going to practice to find the equation of a line given the gradient and a point on the line. So finding the form y equal mx plus c, the equation of the straight line, which now let's start some practice questions. So we're going to practice questions where we're going to find the equation of the line given a gradient or given the gradient or the slope and 1 point on the line. Alright? And we're going to put it in what we call the gradient-intercept form or the slope-intercept form, which is write your answer in the form y equal mx plus c. Now, so we know that ultimately we want our answer to be in the form y equal mx plus c. Now we're given the gradient, so we know our m is equal to 3, and we're given a point on the line, and our point is 1, 2. Now this point will provide us with our x and y values. Now we're going to substitute, yes, algebraic substitution. Algebra is everywhere. We're going to substitute the values for x and y and m into our gradient-intercept form or slope-intercept form, y equal mx plus c, and find the value of our y-intercept, which is the variable c. So we have y is equal to 2. So let me just rewrite y equal mx plus c to show you that we are plugging in the values or we're doing our algebraic substitution. So y is equal to 2, m is equal to 3, and 3 multiplied by 1, which is x, plus c. So 2 is equal to 3 times 1, 3, plus c. So we find the value of c by subtracting 3 on both sides. So c will be equal to negative 1. So now that we have found the value of our y-intercept, we can now go ahead and put it in the form y equal mx plus c. So y is equal, we know our m, 3x, and c is negative 1. So the equation of the line given the gradient 3 and the point 1, 2 is y equal 3x minus 1. Now at this point, I would have wanted you to pause the video and try B. Gradient negative 5 over 6 given the point 9 and negative 2. Write it in the form y equal mx plus c. Yes, pause the video and try the question. The only way to do mathematics is to do it. Pause. Yes, pause. Time for your pause now. Pause it now. Type your solution or type your answers in the chat before I start the solution. Alright, so B, the solution for B. So we know we wanted our gradient, which is M, is equal to negative 5 over 6. So M is equal to negative 5 over 6. And our point, 9, negative 2, which gives us our X and our Y values. So Y equal mx plus c. So we're going to substitute our values in order to find our y-intercept or the value of c. So y is equal to negative 2 is equal, or m, negative 5 over 6 multiplied by 9 plus c. So let's reduce our question, or let's reduce our fraction here. So 3 into 6 goes 2 times, and 3 into 9 goes 3 times, so we're left with negative 2 is equal to, what's that? Negative 15 over 2 plus c. So to find c, we are going to add 15 over 2 to both sides. So this goes to 0, so c plus 0 is c. And negative 2 plus 15 over 2. And that gives us, let's use our calculators, and that gives us 5.5. So the value for c is 5.5. So hence, let's write the equation of the line. So the equation is y equal to m, which is negative 5 over 6x plus, and you could write 5.5 as an improper fraction. So 2 5 10 and 1 11 over 2. It's okay to keep your fractions in this case as an improper fraction. It's okay. Or you could use your mixed number. Alright. So in this set now we're going to look at finding the equation of a line, of a straight line that goes through 2 given points. And in our last video we looked at finding the gradient given 2 points on the line. Now remember, with mathematics it's spiral, so we're always using some past knowledge. Hence, we know what we want it in the form y equal mx plus c. So we want to find the value of our gradient. So we need to find our gradient. We don't know. We have a point on the line, so we can find our gradient and use any point on the line. So read the question keenly. Finding the form y equal mx plus c, the equation of a straight line passing through each pair of points. So a, 0, 1 and 4, 13. So in A, we realize that we don't have our gradient. All they did was they give us the points on the line, or the points that the line passes through. So hence, how would we find our gradient? Now in our last video we looked at using the formula m is equal to y2 minus y1 over x2 minus x1, which we have declared that it is equal to y1 minus y2 equals to x1 minus x2. And if you wanted to go advanced, which is equal to tan the angle. If you wanted to get a little bit more advanced and more sophisticated, we could say it's equal to tan of the angle. But that's for our next video next time. And next, yeah. Anyway, so we have our 2 points. So we have 0, 1 and we have 4, 13. So hence we can look at it as, remember, it doesn't matter. You can let 0, 1 be the ones, and you can let this be the 2s, or you could switch them around and it would still be the same. The answer will still be the same. So m, using your y2 minus y1, so that's 13 minus 1 over 4 minus 0. So our gradient is equal to 12 over 4. So our gradient is equal to positive 3. Now you can take the time, pause the video, yes, pause the video, do your y1 minus your y2 over your x1 minus your x2 and tell me say you get the same answer and move on with your life. So now that we have our gradient, which is 3, I will have now in this case, when we have 2 points on the line, you can choose any point. So you could choose to use 0, 1 or 4, 13. The coordinates, you can use any coordinate, 0, 1 or 4, 13 to form the equation of the line, because both points are on the line and any point on the line will give you the same equation because they're on the same line, or the line passes through all those points. Hence, so we know our m. So it's going back now to what we did in our previous example. So m is equal to 3, and using any coordinates, let's use 0, 1 for now. So then we have y equal mx plus c. Let's plug in what we have. This is our x, this is our y. So that's 1 equal to, now m is 3, x is 0, plus c, which is what we need to find. So we have 1 is equal to c. So the equation will be equal to y equal, let's write it down some more, y equals to 3x plus 1. Now suppose we had used the coordinates 4, 13. Let's see what would have happened. Even though I have already said that we should get the same equation, and we will get the same equation of the line because both points are the points, the line goes through those points on the line. Now suppose we were to use 4, 13. So 4, 13. Now let's check it out. So this is our x, this is our y. So we have y equal mx plus c. So y is our y is 13, m is 3, x is 4 plus c. So 3 4s, 12 plus c. And we have our 13. So to find the value of c, we're going to subtract 12 from both sides of the equation. 13 minus 12 gives us 1, so we get our y-intercept to be 1, which was the same thing we had before. And remember, the y-intercept normally takes the form of 0c, and this is what, 0, 1. So automatically you could have identified your y-intercept without even working out anything. Alright? So hence we have y equal, and our gradient is 3x plus 1. Now some students may be asking why we don't put back a number for x and y. Remember, x and y or xy are coordinates on the line, and we can use any coordinates, and so the general form or the formula is going to be y equal 3x. Now we're going to look at the point gradient form. Now guys, don't get confused. The point gradient form is not the equation of a straight line. It's just a formula that aids us in forming the equation of the straight line. The final answer will always take the form of y equal mx plus c, or you should write your final, I almost said formal answer, boo. Anyway, your final answer should take the form of y equal mx plus c, which is our gradient intercept form, or the slope intercept form, or the general form, which we'll look at in a second, or what these young people say now? In a minute? Yeah, in a minute. Alright. Now what I'm going to do, I'm going to rework the same questions using the point form. I'm going to rework the questions using the point gradient form. So the point gradient form is y minus y1 is equal to m x minus x1. Now we know the m is our gradient, just like that, same way. So a, we have m is equal to 3, and the point 1 2, this gives our x1 y1. So we go ahead and apply our algebraic substitution. So y minus, what is our y1, which is 2, which is equal to m, which is 3, open bracket, x stay the same. Remember, we say that these don't change, minus x1, which is 1. So we have y minus 2, which is equal to, now let's apply the distributive law. So we have 3x, and 3 times negative 1 gives me negative 3. Going to go ahead and group our like terms. So we have y is equal to 3x minus 3 plus 2. So then y is equal to 3x minus 1. And you see that we get the same equation as when we did it before, using only the slope intercept form. Now I want you to pause the video. Yes, pause the video and try B, using the point gradient form to put your answer into your y, in your form y equal mx plus c. Try. No, really try. The only way to do mathematics is to do it. Just do it. Now I hope you have tried the question. I really do hope you have tried the question. And let's go ahead. Let's work B. Our gradient negative 5 over 6, given our coordinate 9, negative 2. So we know m is equal to negative 5 over 6, and our point 9, negative 2, which gives us our x1 y1, and the point gradient form is y minus y1, which is equal to, this is my y, look like g, no? Y minus y1 is equal to m, open bracket, x minus x1. Now let's do our algebraic substitution. Y minus negative 2, which is equal to m. Oh, sorry. We should now apply our substitution for m. So m, give me a minute to do my erasing. Right, so m is negative 5 over 6, open bracket, x minus x1, which is 9. Now let's go ahead. So we have y plus 2, because we know that when the minus and the negative sign multiplies each other, we get a positive. Now we have negative 5 over 6 times x, which gives us negative 5 over 6x. And negative 5 over 6 times 9, and that gives us positive 45 over 6. Alright, now let's go ahead and see, this is an equal sign. Now let's group our like terms. So y is equal to negative 5 over 6x plus 45 over 6 minus 2. So y is equal to, let's do it quick on our calculators. On our calculators, minus 5 over 6x, and we still will get our same 5.5, which is the same thing as 11 over 2. And that's it. Voila! So all the point gradient form, just a formula that helps you to get another way of getting the answer. You do not have to choose this method. This is a choice. I'm just exposing it. There are some students who may prefer using this type or this formula. Who knows? Try, experiment, try something new. And for the final question in this video, I'm not going to work it because we already have the solution. Now what I want you to do is go ahead, find your gradient, just like normal, just like what we did earlier. Find the gradient, use the gradient, and use the point gradient form, and tell me what you get for your answer. You will get the same answer. Just go ahead and try it. Alright, the only way to learn mathematics is to do it. Take the opportunity to practice, 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 practice. You can follow me on Instagram. I do post multiple choice questions. I do plan to post some multiple choice questions and their solutions on my Instagram. MathsMeter. Just MathsMeter on Instagram, MathsMeter on Twitter, and I'm trying to sort out my Facebook account. Also MathsMeter on Facebook. Alright guys, this is it for coordinate geometry part 2. We have 2 more parts left where we're going to look at the general equation of the line, look at horizontal and vertical lines, and we need to look at parallel lines and perpendicular lines, and look at sketching the equations of the lines. Thank you for watching. Have a good day.